saying that we're a different category.
They are just smart.
I like when people ask questions and she just goes, no. I'm like, okay.
Like she's in the
Where I can make lower than that, so I'm just like saying all of this process. Right this year, because I was on it. I'm not with this one. Yeah, hello there, yes. Good.
Yeah, exactly.
It is
B9
because
is folate, right?
I say like somebody runs 9 miles. So folate.
Well, I would know that.
I don't know. I come up with weird things.
Yeah, that's me too.
I frolic through 9 yards. I don't know.
If that was on the exam, that's not
I probably remember on the number.
Probably 9 acres, 9
I don't
yards.
think I'm on the thing because I wrote down the
And Mama says on the last test, she said that she would put the B whatever inside the name. And that messed me up.
I missed.
Oh.
I missed. What's this? Negative.
I hope you like
It's a little black.
Because I haven't done
That's what
too
B
well.
like.
The active form of vitamin D.
I get 6 and 7 out of 10 every single one.
So that's what I know. It's the 1-3 diet. Which I don't know why I missed that. And then hemochromatography, that's hyponatremia.
I made an 80, 16 out of 20. So
I put coenzyme H2O. I don't know what that
I
is.
think I only got to get like, if he has 40 questions on the final, I'm only going to get like
Decarbonylation. Yeah, that. The one, the vitamins that are like involved in the glutathione.
I wonder where she pulls her
This one is vitamin C is
can
not
be a little scary too. Just because that.
You didn't
I
crush
think
it over
that's
A
one.
and
How many blows up? He
Because I remember like
give
I'll
me.
be like,
Oh, yeah, that's the
10,
question.
like I don't even know. I did
Okay.
A.
I was like, I just wasn't.
Because I made a 90 on the
So
test
gene
term.
expression, that was the question. Yeah, I picked the wrong one.
And I studied for like 5 days out because he's scared the shit
Yeah,
out
I'm
of me.
definitely more of a business.
Yeah.
I missed the one about copper. I missed the question about UL, AI, and the pH. The upper, yeah, the upper levels. The
I
upper
probably missed those two.
And then this was the first test.
This was my
I think we
favorite
probably
one.
we only got 22 points on the project. Is it 25?
No, apparently,
I wanted it all.
so everybody does not like
I
chocolate.
don't know, I just wasn't sure if our hands feet thing was the best. Especially when you're like comparing it to people too.
Yeah, they don't really like
That
that.
video. That's why I wanted. I wasn't back there. Yeah. Oh, you were the brother. Yeah.
Well, then they changed it to Brie.
That was like.
It's Brie.
You did really good job with that.
See, in my undergrad, it was all
That
like
was
Brie.
like a healthcare documentary. Like, something you would see.
What's in your course? You ever go to like a doctor's appointment and when they go, if you look through all the numbers? I do.
Free stuff, you pay for that.
Exactly.
Well, I don't pay for it, but
If I'm paying for it,
the
I'm
office pays for it.
okay.
Alright guys, how you feeling? How's the day going?
to understand because of LDLs and HDLs and things like that. That's going to be really important for health in the future. So do you guys want me to start with just all, like starting with chylomicrons and kind of walk you through all of them and what they carry and how they are moved around and the apoproteins? All right. So starting with, let's just eat a meal. So if, let's say, some of you might have already done that. It's not the best food downstairs, but if you did have a hot dog, so you have a meal and it's going to, so of course, obviously it's going to go into your lumen and you're going to have to break down the fat. So you're going to need some bile and some enzymes in order to break down the fat, break down the lipids. And those lipids are going to be absorbed. Essentially, you have this micelle to help bring them in. So I really am starting from the beginning. So you have these lipids that are in this micelle that is going to be able to be brought into the body, into the enterocytes. Enterocytes are the intestinal cells. And these lipids are going to be remade. So you're going to have into the triglycerides, phospholipids, because remember they're remade because they're broken down and then you get them into the cell, you gotta remake them. You also have cholesterol. Actually, it's gonna be cholesterol esters. And that's just means that cholesterol has a fatty acid attached to it. And this enterocyte is going to incorporate all of these into the chylomicron. Chylomicron. So this is carrying dietary lipids and primarily triglycerides because that is mainly what's in your food. So hot dogs are primarily triglycerides. And so that's why chylomicrons are going to be carrying this other thing, but mostly triglycerides. That's the main thing that's going to be incorporated into this chylomicron are triglycerides. And then they're going to be put out into the lymph or the blood. Lymph. And that's right. So lymph, and that's because so all of this fat is going to go into the lymph first, and then it's going to end up in the blood. So it is going to end up in the circulatory system, but the fat, first place it's going to go is into the lymph. Oh, you also have lipid vitamins, so like your vitamins E, A, K, D. So these are going to be also in the chylomicron. But the main thing it's carrying, again, are triglycerides. So it's going to be transported into blood and it's going to deliver triglycerides to tissues. So that's its main function. It's also in the blood, it's going to pick up apoproteins. And the apoproteins are going to be ApoE and ApoC2, which I'll talk about what they do in a second here. So what's the lipoprotein, if you remember, that gives chylomicrons and the other lipoproteins these important apoproteins? HDL. So HDL is the lipoprotein that's going to pass these guys to chylomicrons. That's one of HDL's functions. So HDL, we'll talk about this in a second here, but it does reverse cholesterol's transport, so it's going to take cholesterol from tissues back to the liver. But it also is a reservoir for a lot of apoproteins. And these apoproteins, it's going to pass them to the other lipoproteins, including chylomicrons. So ApoE2 is important for cell recognition, especially liver cell. And ApoTC2 is important for activation of what enzyme? LPL, lipoprotein lipoprotein lipase is gonna be how those triglycerides get out of the chylomicron. So when this, I'll just kind of show you right here. So when this chylomicron, we're in the, so here we're in the blood. Do you guys have any questions before I go? No, I don't mind if you go like wanna chat, but I'm happy to like. So when we're in the blood, so we're chylomicron and we're in the blood. I'm just going to show you how this lipoprotein works. So here's the chylomicron in the blood, so it's got all these triglycerides. This is going to be a little bit of background too. This is going to be a reminder of phosphatidylinositol. That's a big one. So phosphatidylinositol it actually won't be there. It'll be on this. It'll be on the endothelium. So it's going to be like right here is this phosphatidylinositol that's going to be hanging off of it, anchoring it to the cell. Sorry, that's an LPL. LPL. Lipoprotein lipase. LPL. Lipoprotein lipase is going to be hanging out here on the blood. And actually it's anchored here thanks to the, what did I just call it? Phosphatidylinositol. So phosphatidylinositol. Phosphatidylinositol, if you recall, is a phospholipid. It has a few functions. It's a reservoir for arachidonic acid. And it also anchors proteins to cells. And that's what it's doing here. It's actually phosphatidylinositol is anchoring this enzyme, lipoprotein lipase, in the blood. That's one of its functions. So it's a reservoir for arachidonic acid. It also anchors proteins to cells. And this is a protein. So for example, LPL, lipoprotein lipase, is going to be anchored by phosphatidylinositol. All right. Now insulin is going to come along. Because remember, we're in the fed state. And that means insulin dominates. Insulin's going to turn on, insulin's going to help activate lipoprotein lipase. And now lipoprotein lipase can attack those triglycerides and allow these fatty acids to be moved into the adipocytes. And what is the adipocytes going to do for storage? They're going to store them as triglycerides. The fatty acid, so an acyl group, not an acetyl group. And that's when you want to store cholesterol. So that's the lipoprotein lipase. And what activates this is ApoC2 as well. So you need ApoC2. Without ApoC2, and this is ApoC2 is a protein, apoprotein. So this ApoC2, this lipoprotein lipase can't access those triglycerides unless this ApoC2 is there. So ApoC2 is important for activation and recognition by lipoprotein lipase as well.
So that's ApoC2, and then by that, when I said triglyceride, it takes a difference.
Well, so yeah, lipoprotein lipase. This lipase is going to pull off the fatty acids and bring it into the adipocyte. The adipocyte will make triglycerides, new triglycerides out of it. Not much detail, but yes. So essentially, that's how you're going to get those fatty acids from the chylomicron into the adipocytes. It also will pull them into muscles. So your muscles will use fatty acids to make ATP when they're working really hard. But eventually, what's gonna happen to this chylomicron in the blood as it's delivering, so we're still in the blood here. So we have this chylomicron. What's gonna end up is we're gonna just have a chylomicron remnant. Chylomicron remnant. And then what that means is it's basically, it's lost all of its triglycerides. So all the remnant, I can't spell it. Remnant. And so we have a few of these triglycerides left, and we're eventually gonna go to the liver with it. And the liver is going to be able to find this chylomicron remnant because it has an apoprotein is going to be necessary to recognize it by the liver. ApoE. So ApoE, the liver now can recognize this chylomicron remnant and bring it into the liver. So now, that's what the liver does. The liver is going to be able to recognize the triglyceride and bring it into the liver. It's going to recognize the chylomicron and bring it into the liver. That's chylomicrons. I'm just going to go over this one more time. We eat. We're in the fed state. That the food's going to be broken down. Lipids will be broken down. This micelle is going to help bring it into the enterocyte, the intestinal cells. The intestinal cells, the enterocytes, will remake those lipids and put them into a chylomicron. One thing I forgot to mention is chylomicrons have their own unique apoprotein that's going to be put on by the enterocyte. It's going to be ApoB48. APO100 is for LDL and VLDL, whoever's saying that. ApoB48, this one's unique to chylomicrons. And that really is, it's just really for stability. It is for recognition as well, but primarily stability. These membranes are really fluid. You need stability. Proteins add stability. And that's what this ApoB48 is doing, is providing stability to that chylomicron. All right, so now this chylomicron is going to leave the enterocyte, the intestinal cells, and go directly into the lymph, and eventually find its way into the blood. In the blood, it's going to pick up apoproteins, ApoE and ApoC2 from HDLs. HDL, that's one of its jobs, is a reservoir for these apoproteins. It's going to give them to the chylomicron. So the chylomicron now has these guys, and so it can be recognized by these different tissues. So this adipocytes or muscle cells will also now be able to be activated by this lipoproteinase lipase, which will be activated also by insulin. But this ApoC2 is going to allow this LPL to recognize it, lipoproteinase lipase. That way the triglycerides can be broken down and their fatty acids removed and brought into the cell. So it can be adipocytes, it can also be in the muscles. But then you can store, the adipocytes will store the excess fatty acids and triglycerides, muscles will make ATP out of them, and then eventually all that's going to be left is this chylomicron remnant here. And that's going to be recognized by the liver because this chylomicron has an ApoE protein as well. That's going to be recognized by the liver, and the liver can bring in this chylomicron remnant. Now we're going to talk about VLDLs because that's going to come off of what we just talked about with chylomicrons. All right, so we're in the liver. And the liver is going to take all these chylomicrons, pull out the triglycerides, and it's also the liver can also do fatty acid synthesis to make new triglycerides. And this just depends on how much fat you got going on. If you got a lot of fat, it's going to not have to make new triglycerides. But it can also so these are things that the liver makes stuff for the body. It makes clotting factors, it makes cholesterol, it makes urea, and in this case, it can also make triglycerides and incorporate them into a VLDL, a very low density lipoprotein. And these triglycerides are going to be put into this VLDL. And that's what the VLDL is primarily carrying. It's also going to have some cholesterol, but mostly triglycerides. And that VLDL is going to be put into the blood to drop off, to deliver triglycerides to tissues. So all those triglycerides that the liver has, it's going to put them into a new chylomicron called a VLDL, very low density lipoprotein. So this VLDL is mostly triglycerides, some cholesterol, and this VLDL is going to be put out into the blood. And its job, the job of VLDL is to deliver triglycerides to tissues. It's a lipoprotein. They're all lipoproteins. Yeah. It's also going to pick up ApoE and ApoC2 from VLDLs. I'm sorry, not VLDLs, from HDLs. Because remember, HDL is doing that. It's giving away these ApoEs and ApoC2s. So VLDLs will pick that up too. And the ApoE is not as important as the ApoC2. Because remember, you need the ApoC2 to activate lipoprotein lipase. That's the only way it can deliver triglycerides. So the same thing's going to happen. The lipoprotein lipase is going to recognize the C2, ApoC2. It's going to be able to pull out those triglycerides and put it into cells.
So we don't know which one's in the list?
We haven't gotten there yet. Does everyone understand this? Okay, because exactly, that's where we're going to go next. When it delivers its triglycerides, it is going to become an LDL, which is going to have a high concentration of cholesterol. It's got the highest concentration of cholesterol. LDLs have the highest concentration of cholesterol. So it becomes an LDL in the blood. And the function of LDL is to transport cholesterol to tissues. It delivers triglycerides. Once the triglycerides are delivered, it's going to end up with high concentrations of cholesterol. And HDL is also going to give VLDL cholesterol. So all these things are going to make VLDL become LDL in the blood. This is what we're doing in physiology class today. So you guys can't wait for the fourth quarter.
Oh my gosh, I can't wait.
We're going to relax the autonomic nervous system by coloring. So feel free to color if you want to also. So HDL has an added function, what are the functions of HDL? I know we're about to get to it, but one is reverse cholesterol transport. HDL is going to take cholesterol from tissues and bring it back to the liver. It's also a reservoir for ApoE and ApoC2, so HDL can give those apoproteins away. And HDL also gives VLDL cholesterol. Another way that VLDL becomes laden with cholesterol, ultimately becoming LDL.
What about you said it was reverse cholesterol transfer reservoir for ApoE and C2
And it gives VLDL cholesterol. Another reason VLDL becomes LDL, because it becomes laden, full of cholesterol. And that LDL, its function is to transport cholesterol and deliver cholesterol to tissues. And let's talk about how that happens. one thing I hadn't mentioned yet is VLDL also has its own apoprotein. What is that apoprotein called? ApoB100. There it is, whoever said it earlier. Alright, so that ApoB100 is also going to be on the LDL still. It's still going to be on this LDL. ApoB100. So this is unique to VLDLs and LDLs. ApoB100. So let's talk about what it does. We're going to be, let's say we're at a cell here. So this LDL is still in the blood. We're still in the blood. But we have a cell that we're going to come up against. And here is the LDL. LDL. Yeah, we're in the blood. LDL has cholesterol. Lots of cholesterol. I know. I'll take a break here in a second. You guys find another piece of paper. So this cholesterol, remember it has the ApoB100, or LDL has this ApoB100. It's going to be recognized by cells because cells have what recognition receptor? LDL receptor, exactly. So your cells have an LDL, I'm going to write it down up here, LDL receptor. And that recognizes ApoB100. And that is how LDL is going to be endocytosed. Thanks to this ApoB100 recognizing the LDL receptor, you're going to have endocytosis of LDL. The entire molecule will be taken into the cell. Technically, that's going to fuse with the lysosome, and cholesterol is going to be pulled out of it. So I'm just writing fuses with lysosome, and cholesterol is removed. Yep.
So they call HDL high and low because of the protein content compared to.
They're called high and low because of the density, which relates to the protein.
So when it's dropping off, the VLDL is dropping off the triglycerides to the tissues, the triglyceride content is getting smaller, whereas the protein stays the same.
Well, so I would just learn it this way. Anything that has a lot of protein is going to be high density. Anything that has a lot of triglycerides is going to be low density.
So then as it's dropping it off, like, it goes from very low density to just low density because of the concentration.
So I would, like, however you want to learn that, I see what you're saying, but you do need to know that the highest density, the one that's most dense is HDL, the one that's least dense is what? Cholesterol, it's chylomicrons. And chylomicrons have the most triglycerides. Which one has the most cholesterol? LDL. Which one has the most proteins? HDL. That's why it's the most dense. Chylomicrons are the least dense because they have the most triglycerides. So you do need to know that order, however you want to figure that in your mind. But I would mostly think of it like the major things. The least dense, chylomicrons. The most dense, HDLs. And that's because of the protein content in the HDLs that makes them the most dense. Triglycerides are not very dense. If you poop and your poop floats, it's because there's a lot of triglycerides. It's telling you that there's not a lot of density when it comes to fat. So if the fat is there, triglycerides or fat, then it's going to float. It's not very dense. Triglycerides aren't very dense. But proteins are. Proteins are very dense. So anything with a lot of protein is going to be dense. A lot of triglycerides is going to be the least dense. I don't know if that was a good way to help you guys understand that. There you go. But eventually the LDL, that ApoB100, is going to be taken into the cell because it's going to be recognized by the LDL receptor. VLDLs have an ApoB100, but they're not cholesterol yet. Their function is just to deliver triglycerides. But that ApoB100 is only important once the VLDL becomes an LDL, and then that ApoB100 is important because that's how the cells are going to be able to take in that cholesterol. That whole LDL lipoprotein is going to be taken in, endocytosed, in order for that cell to pull out that cholesterol. And that's LDL, so it is delivering cholesterol to tissues. The liver will also make HDLs and put them out into the blood. And an HDL is important for reverse cholesterol transport. That's its major function. I already talked about some of the other functions, the other functions of HDL. And it's going to take cholesterol and brings it back to the liver. So it takes excess cholesterol and brings it back to the liver.
So the liver makes its own HDL to keep the balance.
Well, I would say its own, it makes HDL.
HDL and puts it out there so that more
Yeah.
cholesterol can come back.
And technically, other tissues can make HDL, but liver's primarily the one doing it.
So you modify routines so that you can less LDL. If we have too much.
If too much cholesterol, yeah. But that, I would say, like, the big picture of your liver proteins. And I know it's a really big picture of your liver proteins. And the major apoproteins are ApoB48, ApoC2, ApoE, and the other really important apoprotein that I haven't talked about yet is, no, ApoA1. ApoA1 is on HDLs, ApoA1. And that one is more unique to HDLs, as others can have it, but it's more unique to HDLs. And ApoA1 has a couple of different functions. I'll write in black so that this orange is loud. But the functions of ApoA1 are to activate LCAT. That's a major function. LCAT. LCAT is the C stands for cholesterol. So LCAT. LCAT. And there's another one, ACAT. Either one of these. These guys are enzymes. So the T stands for acyltransferases. So these are cholesterol acyltransferases. And these guys put fatty acids on cholesterol for storage. So that is how it's going to pack those HDLs. It's going to be able to pack cholesterol in here because those cholesterols are going to be stored in that HDL. It needs to store it, otherwise you're going to drop cholesterol. So the only way you can store cholesterol is by putting a fatty acid on it. And that's what those ACAT and LCATs do. Cholesterol acyltransferases put fatty acids on cholesterol to store it. So it doesn't get away.
You have to know like what is happening.
I mentioned that. You should know what statins are for your patho classes, physiology classes, but I'm not gonna. It's like, yeah, I guess I could ask about. I mean, those are just, they're competitive, they're gonna compete with, no, they're going to compete. It actually, it feeds back into biochemistry 1. It essentially competes, it's a competitive inhibition. You remember enzyme kinetics, but I don't wanna go down just know this about the lipoproteins. This is all you need to know about the lipoproteins.
That's all the tests do.
What's wrong with the photograph memory you got?
I will say this is kind of like, this is good for just understanding physiology and medical practices and why different medications that you'll eventually learn about in other classes. I haven't hyper-focused on medications or pathology because, well, I'm more interested in how to keep this human machine healthy than pathology. So, alright, I'm gonna erase this, so unless you guys have more questions about this one. Oh, and that's not. Like, I feel like, I mean, picture's good, but. Alright, so what is another idea of something you guys wanna play with? Cause this is fun, right? We're playing. Of course. We can talk about sort of breakdown. We can talk about
What about digestion? Is your brain on the brain?
oh no, I was just like, we can talk about digestion. My brain is just whatever you guys want to do. Well, we just talked about different proteins, so my head was on digestion of lipids. But we can talk about the new stuff. Or the, yeah.
Can we go back to glucogenic still underneath? Sorry, wait.
Glucogenic versus ketogenic. So that's when we're talking about glucogenic versus ketogenic. My head is trying to wrap my head. So these two terms are related to your amino acids. So glucogenic and ketogenic. This relates to your amino acids. So it's based on the amino acids. So amino acids can be glucogenic, ketogenic, or both. Meaning, so if an amino acid is glucogenic, that amino acid can be converted to glucose. Or TCA cycle, TCA intermediate. Like alpha-ketoglutarate. What amino acid can you turn into alpha-ketoglutarate? Exactly, glutamate. What amino acid can be converted into pyruvate? Alanine. And what amino acid can be converted into, what's the other one? Oxaloacetate. Aspartate. So these are the ones that you need, the conversions you need to know, acetates. That glutamate can be made into alpha-ketoglutarate, alanine can be made into pyruvate, and oxaloacetate, that would be aspartate, can be converted. And these are just transamination reactions. So these are going to be via transamination reactions. I don't know what you mean by that. So ketogenic means that the amino acid can be converted into acetyl-CoA. And I mean, all of this, acetyl-CoA, obviously can be fed into the TCA cycle. Both would be that they can be, that amino acid can be converted into glucose or one of these TCA intermediates and acetyl-CoA. And I only am requiring you guys to know what amino acids are ketogenic, and then you know all the others are glucogenic, or both. Leucine and lysine, the two L's. And then you know all the others are glucogenic, or both. So some can be converted into either one. Phenylalanine. That, I mean, yeah, it is actually one. It's both. Phenylalanine.
Just not gonna ask, but I'm gonna say,
Right.
this is keep.
Don't worry. Don't stress out about yeah. I would ask you, like from this list here, if you know the two L's, then you'll be able to answer any of the questions outside of that. As long as you know you do need to know what glucogenic means and what ketogenic means in reference to amino acids. Something that's glucogenic can be turned into glucose. So oxaloacetate, pyruvate, all of these can ultimately go through gluconeogenesis and be converted to glucose ultimately if you like really eat. Yes. Savannah, that's your dog. No, I'm sorry. I did. Can I get credit for this, Christy?
I love how you take credibility here.
Thank you. You miss lipoproteins. You could have done that one. You look like you're about to take a nap. You look like as excited as my students here.
I'm exhausted today, and I apologize to all of you for being so.
We just need the name.
Yeah, you just need the name.
You're smiling, that's all.
I'm usually always smiling. It's usually a pretty good day to be Dr. Freeze.
Regardless,